All right, so you could solve that like I'm doing, just finished, 116 degrees. And that would be the measure of each one of these angles, 116, 116. This is the long way to do it. What I think most of you would do, probably, is you would take your calculator and you would add these together. 85 plus 43. That's 128. Then you would take 360, the total number of degrees in a quadrilateral, and subtract 128, which is 232. That's the amount of degrees left, but since they're congruent, we can divide that by 2, and that gives us 116. I imagine most of you would go about it this way, but just so you can see how it would look longhand, it would look like that. All right, so those are the basics of the properties. Now we're going to do a couple examples involving algebra for some clarity, and then you'll be able to practice. And I think I'm going to add an extra example because I feel like I left out a good one. All right, if PQRS is isosceles, and also please notice that PQRS goes around the shape, not like PQRS. It needs to go around like that. Okay. We want the measure of angle P. So I'm going to go ahead and color in angle P so I don't forget that once I find X and feel like I'm done, so I don't forget. In a trapezoid, all trapezoids, the consecutive angles, the ones on the same side, are supplementary. But this is isosceles, which means that it has extra properties. And you can look at this a couple ways. One, you could move the 5x plus 4 over here, which is what I'm going to do. Because in an isosceles trapezoid, base angles are congruent. So these two have to be the same. Now we can use the property that consecutive angles between the parallel lines are supplementary. I hope I said congruent. I feel like I didn't. The base angles are congruent in an isosceles trapezoid. Okay, so if these are supplementary, that means that we add them together and set them equal to 180, which you guys have been really good at. So make sure you just keep trucking. All right, solve that. All right, so x equals 12, which many people would be tempted to stop, but because I say it all the time, I think that you guys know you found x, let's make sure that's the answer. Well, what we're looking for is the measure of angle P. Angle P is equal to 5x plus 4, so we actually need to substitute x in. So 5 times 12 plus 4 is 64. So angle P is 64 degrees. That's the actual answer. All right, let's move on. KJLM is a kite. And we want to find the two missing angles. Since this doesn't involve algebra, I'm not going to highlight them because we'd be highlighting both. Rules of a kite, the angles in a kite. Opposite angles are congruent, one pair of them. So that has to be 82. In a kite and all closed quadrilaterals, there are convex quadrilaterals, there are 360 degrees. So you're going to add up all those numbers. And then subtract from 360. That's it. Okay, when it's just numbers, it moves pretty fast usually. All right, hopefully you're seeing these patterns. If this is an isosceles trapezoid, we want to find all the missing measures listed down here. Move it so you can see it. Okay, so OP. By isosceles, it means that that opposite pair of sides are congruent. So these have to be congruent, which means that OP has to be 11. And then CO is congruent, like I said on the other page, to this one right there. So that's 8. and NP is this whole segment here. All right, so based on what we see over here, we know this piece is 14. So the whole thing would be 8 plus 14, which is 22. Not degrees, because those are lengths. Those actually should be feet, but I didn't write that part. All right, is everybody good, hopefully? Let's keep going. A kite. All right, the coolest thing about a kite is that the first thing you should do if you have the diagonals is draw your little right angle mark in there. We want to find these things down here. There's 3 of them, so I'm going to move it up because we know it's a kite. All right. The first thing we want to find is the measure of angle GDE. So I'm going to highlight this to keep it color-coded. GDE is this whole thing. Well, we talked about how the kite, or the diagonal in the kite, this long one, bisects this angle and that angle. So bisect means, hopefully you said in your brain that it cuts it in half. So if that's 59, this is also 59. So that whole pink angle would be 59 plus 59, or 59 times 2, which is 118 degrees. I'm just going to write it out here. It's a terrible place to write it, but that's the measure of the pink angle. All right, DEH, this one right here. Well, hopefully you can see. Well, we could do it 2 ways, but I'm going to look at it this way. This is a right triangle. So I'm going to draw it over here just so you can really see a little more clearly, since you're still learning. That's 90. This one is 59 degrees. We want to know this angle here. Should we use the Pythagorean theorem since we know 2 angles? No, and hopefully you said that to yourself. Absolutely not. This is angles, not sides. Can we use trig? No, because that's sides and angles. This is just angles, and we all hopefully know that the angles in a triangle add up to 180 degrees. So simply, you would add these up, 59 plus 90, 59 plus 90, and then subtract from 180, which is 31 degrees. So this angle is 31 degrees. All right, and then lastly, angle DGH. DGH, right here. And I'm going to do this kind of a crazy way, just because I want you to see all of these things. And you can do it other ways too. I just want to make this really clear. DGH. The way I'm going to look at it is I'm going to look at this orange triangle I'm drawing here. That is an isosceles triangle because in a kite, 1 set or 2 sets of consecutive sides are congruent, which forces this to be an isosceles triangle. In isosceles triangle, base angles are congruent. So if this one's 31, that also has to be 31 degrees. Okay? So you can see hopefully how right triangles, how isosceles triangles, how all these things we've been learning all semester, parallel lines, everything is kind of mixing together into these quadrilaterals. It's like soup. All right, this one does not say that it's a trapezoid anywhere, but because we know one set of lines are parallel, that by definition makes it into a trapezoid, which follows trapezoid rules. In a standard trapezoid, the only angle rule we can follow is that consecutive angles, the ones only between the parallel lines, this one and this set over here, are supplementary angles. Supplementary means they add up to 180, so we're going to add all this stuff up, 14x minus 15 plus, I'm going to wait and finish that on the next, last video.